Hello and welcome to today's lesson. We are looking at rate of change and slope and still looking at the same essential question, how can we use proportional relationships to solve real world problems? So as we get started on that today, please make sure that you have your notes page ready to go, as there are blanks and things to fill in along the way. So once again, make sure you are filling in those notes because I will be checking them later on today. So our objective here for today is that you all, the mathematicians in this classroom, will be able to calculate the rate of change or slope from a table, from a graph, and from ordered pairs. So 3 different ways that we will be calculating slope here today. So to get started, please take a moment and jot down some things. You should have learned about slope just a little bit last year in 7th grade. So if you please take a moment to write down some things that you remember about slope, and then when you are done you can resume the video. Alright, welcome back. So you should have some thoughts here about slope, things that you might remember from 7th grade, but here is what it is. Slope is a measure of steepness of a line. So the larger the slope, the more steep the line is. The smaller the slope, the less steep the line is. So when we have slope, we have a couple different types here. We've got a positive slope, looks like it is going up a hill from left to right. And we've got negative slope, which looks like it is going down a hill from left to right. So positive looks like it's going up and to the right, uphill, and negative slope appears to be going down from left to right, down a hill. One way that we can keep those straight, if you take your pencil and do not draw on your screen, but hold your pencil kind of up to your screen, and if you move your pencil from left to right, you can visualize a ball rolling along with your pencil or seeing that it's moving up or down, and that can help with that positive and negative slope there. We have 2 special kinds of slope that you will see today here on this notes page, but we are not going to focus on them right now. We do have zero slope and we have undefined or no slope. So those are more considered kind of more special cases. So like I said, today we're going to focus on the positive and the negative slopes that we can be calculating, again, from a table, from a graph, or from ordered pairs. Okay, so we first have a your turn question, but we are going to work on this together. What do we remember about slope? Well, this graph says or is showing the rate at which water is leaking from a tank. So the slope of the line is the leaking rate in gallons per minute. Find the slope. And then it has these words rise over run. Well, you might remember that sometimes we do refer to slope, that steepness of a line, as rise over run. That should hopefully sound familiar to you. So as we look at rise over run, well, I know that rise would be like the sun rising, so going like up and down. Run would be like, a person running left to right. They don't run up into the sky. So when I'm looking at the rise, I'm looking at the up and down distance between my 2 points. So I'm looking at this distance here. I went a little bit too far there. I apologize. So looking at the up and down distance, so my rise or my distance and my up and down is 1, 2, 3 units, and I can just use those hops to kind of help me visualize and count. And then I can look at my run or my change from left to right, and that is 1, 2, 3, 4, which is my run. And so then in order to actually write that as the slope, I am looking at rise of 3 over run of 4. So my slope is 3/4. Now as we work with slope, it is okay and actually good to leave it as a fraction. It's also okay to leave it improper if you need to, but we will be wanting that slope to remain a fraction. So the slope in this one, or the rate at which the gallons of water are leaking, is 3/4. Let's take a look at another one here. So if we take a look at this one, we have 2 points here drawn on this graph for us once again, and I am trying to calculate the slope or the rise over the run. So when I look at that, I look at the change in the rise, or the change in the up and down. 1, 2, 3, 4 this time. And my change in run, 1, 2, 3, 4, 5, which makes my slope 4/5. Okay, now one thing that I did forget to point out on the last question, but I do want to make sure to point out here, you will notice that this line appears to be going up and to the right, which means it is a positive slope. There will be some times where you will encounter a negative slope pointing down and to the left, more like this one here. And that just means that if you were to have a slope like that, you would need to put a negative sign out in front of your slope. Okay, so let's take a look here at one more. The one last thing that I do want to point out to you, you'll notice that on this graph we do not have any points drawn for us. So it is extremely important when we are drawing points to draw them in the perfect corners. So for example, this specific line does actually cross nice and neat there right in the middle at the origin. But if you continue to look here, this point right here, the line does not cross right in the corner of those boxes. So that is not a good place for me to draw a dot. This one is actually not good either. That one's not quite there. So I'm just going to continue to look either up or down my line. Doesn't matter which direction. This one doesn't look very good. This one does not look good. This one is still not very good. I do see one clear down here. And also, if I continue straight up my line, I do see one up there. So I do not want to use the X's because once again, where those X's are, I'm taking them away so you can see that line. Where those X's are, we do have that line, but it does not cross right in the corner of those boxes. So it's not going to be a perfect point, and it's not going to help us with the slope. Now you might be asking yourself, why do you have 3 dots? I'm just showing you the options. You only need 2 to calculate the slope. So I'm going to use the one in the middle and the one at the top. Now the one thing that I do notice about this line is not going uphill, it is going downhill, which already tells me my slope is negative. So I'm going to write that negative sign down so I don't forget. And then I'm going to count the rise and the run. So the rise is 1, 2, 3. And the run is 1, 2, 3, 4. So my slope is negative 3/4. Negative 3/4. All right, so slope is also sometimes referred to as rate of change, and this is something between 2 points. What you have already been doing, counting the slope on a graph, is actually you doing that when it's on a graph, but what if we have values that are not on a graph? What can we do? Okay, we have a formula that we can use to help us find the slope when we do not have a graph, and the formula is sometimes written like this. M, or slope, may be written as the triangle y divided by the triangle x. So what is the triangle? Well, the triangle is the difference between 2 y values divided by the difference between 2 x values. So that triangle stands for the difference or the change in the y values. So more commonly, we actually have the formula written like this right here. y2 minus y1 over x2 minus x1. And that is going to be extremely important as we continue on here. So once again, the slope of a line is the ratio. Remember, ratio looks like a fraction. The ratio of the change in y values, or the rise, corresponding to the x values, the run, rise over run. So we're doing a similar thing here, but just what happens when you don't have a graph. So let's take a look here and try a few out here. So first, finding the slope between these 2 points. Okay, I have 4, -3, and 5, -2. So I'm actually going to write 5, -2 underneath the 4, -3, just to help us out here. When I am looking at this, I remember that just a moment ago it told me that the formula was y2 minus y1 over x2 minus x1. So that formula is going to be extremely important. And as I look at my points, I see y's and x's. So I know that in ordered pairs, the first number is always the x number, and the second number is always the y number. So as I look there, my two x values are 4 and 5. My y values are -3 and -2. So I've got that set up. But what are these 1s and 2s? Well, as I look at that, my 1s and 2s here, we can take a look here and give us a point number 1 and a point number 2. So why am I doing that? Well, to help me with the formula here. So these are my x values, and here I have my y values. And then I'm going to go ahead and also highlight here, this is point number 1, and this is point number 2. Tried to use a different color there. So kind of got this little grid set up to help me here. So when I'm looking for y2 to be the first number in my formula, well, I know that -3 and -2 are my y numbers, but which one is y2? Well, here's the y, here's the number 2, and where those two things cross is actually the -2. So that's my first value. In my formula, it shows me the subtraction sign, so my problem is always going to be subtraction. And then I'm looking for my y number 1. So my y values are still over here, but I've already used this second one from point 2, so now I'm going to be looking at the first one, -3. Then I'm looking for x2, so my x values are here in the yellow, and then my point 2 is that peach color, so where the peach and yellow cross, I've got the 5, and x number 1 then is the 4. Once I've got those numbers plugged in, I just need to subtract and simplify if possible. -2 minus -3, well, I can do keep, change, and that tells me -2 plus 3, different sign subtract tells me 1. And 5 over 4 is also 1, which means that the slope for this first set of points is the number 1. All right, let's take a look at the second one here, -5 and 9. Once again, point number 2, point number 1, x number 2, and x and y. Sorry, x and y. So how can I use that again to help me? Well, y from number 2 is 9, y from number 1 is 6, x from number 2 is -5, subtraction always, and x from number 1 is -3. 9 minus 6 is 3. Gonna keep, change down here. -5 plus 3, subtraction, and I end up with -2. So this slope is an improper fraction that cannot be simplified. 3 over -2. Alright, so now that you've done 2 with me, why don't you take a moment, please pause your video and give these 2 questions a try. When you are ready to check your answer, go ahead and press play to resume and check your work. Alright, welcome back. Let's take a look and check roll here. Instead of doing the highlighting, I am going to show you another way that you could look at this. I know that this is x and this is y, this is x and this is y, because the first value in ordered pairs are always the x. And then I can say, well, this is number 1, so these are both 1s. This is point 2, so these are both 2, and I can plug things in that way. So y2 minus y1 over x2 minus x1. Y from point number 2 is -5, subtraction problem. Y from number 1 is 6. X from number 2 is 2, and x from number 1 is also 2. So -5 minus 6, I can keep, change, and see that that is -11. 2 minus 2 is 0. Now I know I told you we were mostly focusing on our positive and negative slopes here, but this one is actually one of those special cases. When we have a 0 on the bottom, you're actually not supposed to divide by 0. If you type it in a calculator, you will get an error. So this is a no slope answer. If you don't remember that or don't quite understand that right now, that is okay. If you can at least get to the 11 over 0, or the negative 11 over 0, I'm sorry, then you are on the right track. Let's take a look at the second one here. X and Y, point number 1 and point number 2. So we have negative 8 minus 0, negative 5 minus 3. So negative 8 minus 0 is negative 8. Keep change here and also get negative 8. Negative 8 divided by negative 8 is 1. So my second one has an answer of 1 for the slope. All right, so let's take a look here at the next piece here. This is the last piece of our objective. We have found slope from a graph. We have found slope from ordered pairs. And so what about a table? Well, you'll actually find that a table is basically the same as finding it from two of the ordered pairs. We've got our x and our y already labeled here for us. We just have to decide which one is point number 1 and point number 2. The nice thing about this is we can actually choose any point as number 1 and any point as number 2. Typically, I do see students not liking the negatives or avoiding them because they don't want to make a silly mistake. So it's completely okay if you would like to skip that first one and jump down to these other two down here and say that's point number 1 and point number 2, the second and the third. So as I follow my formula here, y2 minus y1 over x2 minus x1. Well, y number 2, y value from point number 2 is 20. Y value from number 1 is 6. X value from number 2 is 7. And x value from number 1 is 4. So at this point I can subtract and then simplify if it's possible. 20 minus 6 is 14. 7 minus 4 is 3. Now, I do see that that is improper, however, improper is okay. And so as I look at that, I cannot simplify those by the same value, so I'm going to leave it as the improper 14 over 3. All right, as you see this question here, if you would please take a moment and pause your video and give this one a try on your own, that would be great. When you are ready to check your answer, please resume the video and I will show you the answer and you can ask any questions if you have them. All right, welcome back. So once again, that formula, y2 minus y1 over x2 minus x1, so I can just decide point number 1 and point number 2. y2 is 3, y1 is 5, x2 is 7, x1 is 5. So 3 minus 5, when I see 3 minus 5, I have on the top of my head already that this is a negative number, so this is actually negative 2. And then 7 minus 5 is positive 2, so when I simplify that fraction, they can both be divided by 2, which gives me negative 1 over 1, which is the same thing as a slope of negative 1. All right, so our objective for today was that by the end of this lesson, you would be able to, you mathematicians, calculate the rate of change or slope from a table, graph, and ordered pairs. And now that we have gone over those three things, I hope that you have a better understanding of them. If you still have questions, you should raise your hand and I will come to help you individually. When you are done, or as you are done with this notes page, please also show me your notes page so that I can see what you have done so far and give you the practice assignment for today.